Greetings all and welcome back. We'll be working on week 4, day 3. This will be my last day with you, and then Mr. Bernal will take over with week 4, day 4. I hope you enjoy him as well as I have enjoyed working with you. Alright, let's get ready for our daily fluency. We're going to use the place value chart to solve the problem. Show your work. The first problem is 28 plus 10. Please press pause. Okay, 28 plus 10. So I've taken it from its horizontal form and I've written it in its vertical form, going up and down, making sure that I lined up my ones and my tens. So now I'm ready to add. 8 plus 0 equals 8. 2 tens plus 1 10 equals 3. My sum is 38. Now, please go over to the next problem. 27 minus 19. Please press pause. Now we're looking at the problem 27 minus 19. I've taken it from its horizontal form and I've put it into its vertical form, going up and down, making sure to line up my ones and my tens. So let's look at this. 27 minus 19. When I go to the ones place, I see I have 7 minus 9. I know that when I have to subtract, the number at the top should be bigger because I'm taking from it. So I ask myself, can I take 9 from 7? No way. I can't do it. So since I can't do it, I have to do what? I ask myself, can I bundle 1 10? So I'm going to take a 10 from my tens place, leaving me, instead of having 2 tens, now I only have 1 10. I take that 10 and I bring it to my ones place. I unbundle that 10 into 10 ones. 10 ones plus 7 ones gives me 17. 17 minus 9 equals 8. 1 minus 1 is 0. So therefore my difference is 8. Okay, so we've been looking at making arrays today, and when we make an array, we're looking at rows and columns. So on our anchor chart, it states that when we have a row, the row goes side to side. So in this problem here, I have 3 rows of 2. So I have to draw my 3 rows. Row 1, row 2, row 3. Remember, rows go side to side. Next, it tells me how many will go on each row. 2. 3 rows of what? 2. I'm going to put 2 chips on each row. 1, 2. 1, 2, 1, 2. So I have 3 rows of 2. Now, I'm going to take what I see here and use what we did yesterday when we talked about writing repeated addition sentences. Let's see which number repeats on each row. 1, 2. How many do I have here? 1, 2. How many do I have here? 1, 2. Therefore, I can write this as an addition sentence. 2 plus 2 plus 2 equals. In order for me to find the total amount, I will have to count it together. So I'm going to add everything together. Let's count. 1, 2, 3, 4, 5, 6. So 2 plus 2 plus 2 equals 6. I can also look at it this way. Well, what number did I add together? What was my number that kept repeating itself? It was the number 2. So 2 added. Now how many times did I add it together? Let's see. I added together 1, 2, 3. 3 times because I had 3 rows. 2 added 3 times. So if I had 2 added 3 times, what would that equal? 2 added 3 times equals 6. All right. Let's look at another way of looking at how to make an array. Now let's look at a new problem. This time we're not looking at rows, we're looking at columns. We're still building arrays though. Remember, arrays have both rows and columns. So when I have 4 columns of 3, when I'm thinking about a column, columns go up and down. So let's look at this. 4 columns. 1 column, 2 column, 3 columns, 4 columns. So I have 4 columns. How many chips am I going to put on each one of those columns? I'm going to put 3 chips. So watch me. 1, 2, 3. And the way I like to do it in columns so I don't get confused is I like to build on top of my columns. 1, 2, 3. Now I'll go to the next column. 1, 2, 3. And my last column. 1, 2, 3. Okay, so now I have 4 columns of 3s. How can I take this and write this as a repeated addition sentence? Well, let's see. What's repeating itself here if I'm looking at columns going up and down? So let's see. 1, 2, 3. That's 3 here. 1, 2, 3. 3 here. 1, 2, 3. 3 here. 1, 2, 3. 3 here. So there's 3 on each column. So I would write my repeated addition sentence as 3 plus 3 plus 3 plus 3 equals. Well, in order for me to find out what it equals, I have to count them all together. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 plus 3 plus 3 plus 3 equals 12. Another way that I could look at it, let me see, I was adding which number again? 3. So 3 added how many times did I add the number 3? 1, 2, 3, 4, added 4 times, equals 12. So 3 added 4 times equals 12. Okay, so let's look at the next slide and see what other goodies we have in store for us. Let's look at some more and different arrays. In this array, I have 3 rows of 3. The picture is already made for us. We have 3 rows, and on each row we have 3 chips. How would I write this as a repeated addition sentence? To write this as a repeated addition sentence, I would write 3 plus, how many do I have here? 3. Plus, how many do I have on the third row? 3. Because I have a 3 here on the first row, 3 on the second row, and 3 on the third row. Now, if I want to find out what it totals, I would have to add everything together. So let's do that. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 plus 3 plus 3 equals 9. But let's take this up a little bit higher. Let's make this problem a little bit more challenging. Let's see, how can I make this challenging? Let me think. So we made this problem just a little bit more challenging for us scholars because we're making sure that our math is still ticking up there. Let's give ourselves a challenge. How would this problem change if I added one row? So I'm going to add a row to what I already have. Let's see what happens. If I add a row, am I going to have to add some chips? Of course. So I added a row. Now I need to add 3 chips. 1, 2, 3. Does that change the way that I would write this as an addition problem? It sure is. Because on my 4th row, I have 3 chips. So this would now be 3 plus 3 plus 3 plus 3 equals. So let's go back and count this. If I have 3 on this row, 3 on this row, 3 on this row, and 3 on this row. Now I'm going to add 3 4 different times. Let's do it. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 plus 3 plus 3 plus 3 equals 12. Wow, good job, scholars. All right, let's look at a different problem. Today, we're going to be looking at 2 columns of 5. So, as you can see, the chips have been laid out for us. We know columns are going up and down. So I have column 1 here, column 2. On each column, I should have 5 chips. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 5 on each column. Now, how would I write that as a repeated addition sentence? I would write that as 5 plus 5. So 5 plus 5 would equal, let's see, let's count it all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 plus 5 equals 10. I wonder, can we turn this up a notch? Can we make this problem a little bit more challenging? Well, let's see. All right, you know how Miss Best like to turn it up a notch to make sure that you're doing your critical thinking. So now let's look at what we're going to do to this problem. It says, if we add 2 columns, how would this problem change? So we know columns are going up and down. So this time we're going to add 2 additional columns to what we already have. So I'll start on this side. 1, 2. So those are my 2 columns. Now, because I have my 2 columns, am I going to need some chips? Yeah, better believe I'm going to need some chips. How many chips am I going to need to complete this first column? Well, it tells us here I have to have 5. Let's count. 1, 2, 3, 4, 5. Now, I still have my second column that I had to add. Am I going to need chips for that? You better believe. Let's put it up. 1, 2, 3, 4, 5. Now, has that changed my problem? Yeah, better believe it's changed my problem. So let's see how I would write this as a repeated addition sentence. Well, I have 5 here on this column, 5 here on this column. Those are the 2 columns that I added in. 5 on my existing column, 5 on the column that I started off with. So let's see, how many do I have? I have 1, 2, 3, 4. I have 4 5s that I'm going to add together. So my problem would be 5 plus 5 plus 5 plus 5. Now, let's see what that will equal in total. So that means I have to count everything together. Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 5 plus 5 plus 5 plus 5 equals 20. I knew you were a smarty pants. All right, we're going to really do a quick recap of what we've learned so far in our videos. So when we look at this array, we look at only those in the shaded black triangles. So we have 3 rows of 4, which equals 12. We have 3 rows, 1, 2, 3. We also can look at it as 4 columns of 3. So we have 1, 2, 3, 4. That also equals 12. If I wanted to write that out in an addition problem, I would write that as 4 plus 4 plus 4 equals 12. But now, what if I wanted to take it up a notch? What if I wanted to make it a little bit more challenging? Well, we know that to make it challenging, I'm going to add, it says a row. That is represented in the white triangles that we have. Now, when I take what I had, which were the 3 rows of 4, which equals 12, add another row of 4. They want to know how many triangles do I have now. You should have 16. Well, let's look at the let's try it together part. This says that I'm going to use the arrays of the smiley faces to answer the following questions. Let's do number 1 together. Blank rows of blank equals blanks. Remember, rows go side to side, left to right. Pause the tape here and write down your answer, please. If you said that 3 rows of 5 equals 15, you are correct. Now let's go to part B. Pause the tape here and write down your answer, please. Now, if we look at B, we see that we have 5 columns. Columns go up and down. Those are represented by the yellow lines. 5 columns of 3 equals 15. So let's go to part C. How could I take part A, look at the rows, and write it as a repeated addition sentence? Well, if I look at it as a repeated addition sentence, it would be 5 plus 5 plus 5. Now let's go to part D. Add 1 more row. How many smiley faces are there now? Please press pause. If I add another row of 5 to the 15 that I already had, I would have come out with the answer of 20. Now, click to the next slide. Okay, my lovely math scholars, you're going to work on the rest of these problems on your own. You're going to complete each missing part to describe the arrays. Do your best job. I know you can do it.